Okay, I'm back after a long hiatus. In this video, I'm going to cover handling the adjusted close for daily numbers from the CSV file we downloaded from Yahoo and loading them into the ARFF files. Sometimes the high, low, and close are needed for technical analysis functions, and the data from those fields will need to be adjusted. And then I'll show you an example using the Williams ultimate oscillator function. In the previous videos, I only used the closed from the CSV file that we pulled from Yahoo. The close that we used was called adjusted close by Yahoo, and it was its fifth column in the file. But what if you have a function that needs the open or high or the low of the day? Well, you need to adjust that data because the adjusted close column 5, represents data that prices that have been split or dividends have been applied. So we'll need to come up with an adjustment factor for the opens, the lows, and the highs for the day. From the CSV file, we take the adjusted close in column 5 and divide it by the actual close in column 4. This will become our adjustment factor. Now, to get an adjusted open, high, or low, we just simply multiply our adjustment factor against column 1 data for the open, column 2 for the high, and column 3 for the low. We could apply it to the actual close field, but that would be redundant. We just simply use column 5. The ultimate oscillator function uses a high, low, and close data for each day. So we will have to adjust this data. In the previous videos, the CSV data from Yahoo was temporarily stored in an array list, and then all the data was finally moved to double arrays for the ta-lib functions. For the example programs in this video, the high, low, and close will be adjusted, stored in separate array lists, and finally moved to 3 distinct double arrays. I will present 2 ultimate oscillator examples, one with all numerical attributes. The ARFF file contents will be the current and previous day's ultimate oscillator value along with the percentage change as the classification attribute. And then the final example will be all the values will be, attributes will be nominal, string values representing a data range for the current date and the previous date, for example 80 to 100% or 0 to 20%, and an indicator also if the value is rising or falling. So here we are into the 2 programs. One will be doing a classification of a buy or sell, and the second one will be doing a regression, trying to predict the price. We'll look at the regression program first. As you probably know, the ultimate oscillator is not designed to do price prediction. It's used as a overbought or oversold indicator to help you make a decision to buy or sell, but we will just be using this program to help us see if we can find out if it will give us a decent future price prediction. Like all the other programs, we're going to do a 5-day look ahead. We store our ARFF file headers in a string writer. This particular program is going to have 3 attributes. The first 2 for the calculation of the current day's ultimate oscillator and the previous day ultimate oscillator, along with the regression result value. All 3 are numeric. We read in our SPY file, our CSV file that we got from Yahoo, skip the header, create 4 array lists, the 3 that we're really interested in, the high, low, and the close. As we read in the CSV file, we pull the adjusted close column and store it in a double, get the actual close value for that day in column 4, compute the adjustment factor, which is simply the adjusted close divided by the actual close, and then we're going to store the adjusted high by pulling column 2, which is the second column in the CSV file, and multiplying it times the adjustment factor. Again, for the low, which is in column 3, and we'll pull that and multiply that times our adjustment factor. Store the adjusted close and the date. We have to ta-lib requires a double arrays, so we move everything out of the array lists into a double array, the high, low, and the close. We calculate the 5-day moving average to give us the trend, and we're going to do and this will be used to smooth out the data, just like we did in the other programs. Store our results in a CSV file, but we'll also display it on the console. And we're going to go through the 3 loops that the ultimate oscillator function requires, such as fast, medium, and slow intervals. Fast will be going from 2 through 15. The medium will start about 5 above 2 and go through 25, and the slow interval will start about 5 intervals above medium and go up to the value of 35. This is where we'll be storing the ultimate oscillator values for each iteration. We call the ta-lib method ultimate oscillator, passing it the high, the low, and the close or double arrays, along with the intervals of fast, medium, and slow, and everything is stuffed into the our ultimate oscillator double array. We do the realignment because ta-lib does the offset. Everything starts at 0, the results, so we push everything back to where it should be so it lines up with our dates. Here we build our training and test ARFFs, store them in a string writer, load the ARFFs with the headers, and then we go through the entire array, output array. If everything is, if the date of that current index value is greater than 2018, the results will be stored from PA. The results will be stored in the test ARFF file. Otherwise, everything's going to go into the training ARFF file. Again, we simply that ship's wrong. That should be like that, and that. Not that it matters, but the current date ultimate oscillator, the previous day's ultimate oscillator, and the percentage change from the 5 days ahead smoothing divided by the current close. Build our training instance, build our classifier, and I always use the random forest classifier and load in the training instances. Build the test instances, which I could have waited to do. Call our evaluation, and build the evaluation object using our training instances, and then call the evaluation object's evaluate model, passing the classifier and the test instances. Display the intervals, the correlation coefficient, and the mean absolute error values for each iteration. It takes about 2 hours for this to run because of the size of the intervals is pretty large, and regression takes a little longer than classification. The classification program is pretty much the same, except in this case the classifications are stored in strings, and the strings show the range of values for the ultimate oscillators for the current and previous day. Depending on if the value is between 0 and 20, or 20 and 40, 40 and 50, 50 and 60, and so on. We also have one other attribute, or two other attributes: the current, if the current day is rising, or the previous day oscillator is rising or falling. And then we're going to do a nominal classification in our result classifier attribute, and it's a value of either a buy or a sell. Everything else is pretty much the same up until the iteration. Again, if the date is greater than 2018, our results will be stored in the PW test, otherwise it'll be stored in PW train. Based on the value of the oscillator, the string values is 0 to 20, 20 to 40, 40 to 50, 50 to 60, 60 to 80, and 80 to 100, simply by just doing compare less than 20, less than 40, and so on. Okay, we do it for the current day's oscillator and the previous day's oscillator. Compare the current day oscillator to the previous day oscillator. If it's less than, and it's falling. Otherwise it's rising, and then take the previous day's oscillator value, compare it to the day before's oscillator value. Again, it's either rising or falling. And if the SMA close is greater than the close, then it's either a buy or a sell. That's SMA period. Let me just change this here. Period. So if the moving average, which is our smoothing of the closes over 5 days, is still greater than the close, it's a buy situation. Otherwise it's a sell. This one runs a little faster, and since I changed the attribute there, I'll have to rerun this. The numeric or the regression program's already been run, but this one with its change hasn't. So I'll have to run this, and I'll get back to you as soon as I can. Okay, so the programs have run. The first output we'll look at is from the regression classification, and we can see we have our 5 fields that we sent to our CSV file. And the most important thing is that we want to do is look at a correlation coefficient, and we want to sort this on that descending. Why doesn't it recognize the header? I don't know, but we'll just do that. And we want to do that descending, because the value closest to 1 would be the best. And the value near 0 obviously doesn't mean anything. And the best we can get is 0.21, which really isn't all that great. But then again, Ultimate Oscillator wasn't designed to do price prediction. And that's what we're trying to do with our regression. If we take a look at the buy-sell classification, we have the, we'll take a look and we'll sort it on weighted precision descending, because we want a high weighted precision value. The higher the better. And we, I don't know what happened here. Sort. Descending. There we go. And a little bit better. A lot of them are a little bit better than 3/4 of our prediction were accurate. So let's combine the two. See if any of the intervals, fast, medium, slow, match or come close to each other. Copy. Go to our numerics. And let's paste that. And as we can see here, 4, 133, 5, 12, 4, 16. I don't see anything where either they both methods produced a comparable fast, medium, slow iteration value. Probably the best would be this 522. 522 is probably the best we can do. But still, with the classification of a buy or sell, it's pretty accurate. 3/4 of the time it's accurate. Okay, so on to the next video, and that will be about ensemble, using a collection of methods or classifications to produce a decent buy, sell, or hopefully a price. This is nothing similar to the 4 regression classifications already built into WEKA. This is an ensemble of different classifications using different technical analysis methods that I use. Until then, press the like button and subscribe at the same time.